Number 6 on this list of integrals from a Princeton professor, or professor at Princeton University, I should say. Integral from 0 to pi over 2 cosine x over 4 minus sine squared x dx. So when I see this integral, right away I see that I can make a substitution. U is sine x, du is cosine x dx. Maybe that will make things a little nicer. And then because this is a definite integral, we got to change the limits of integration as well. Okay, so I get integral from 0 to 1 du over 4 minus u squared. The bottom, I can factor it as 2 plus u, 2 minus u. This is a typical partial fraction decomposition problem now. All right, so I'll go over the steps here. So this 1 over 2 plus u, 2 minus u can be broken up into some a over 2 plus u plus b over 2 minus u. If you're not familiar with partial fraction decomposition, I would recommend you go watch my crash course video on partial fraction decomposition. I have a bunch of videos that hopefully can be helpful for you if you're really struggling with the fundamentals before we even get to harder integrals. Okay, so from here, multiply both sides by this denominator, I would get 1 equals a times 2 minus u plus b times 2 plus u. We can plug in nice numbers like u equals 2 because this term would go away. Then we get 1 is equal to 4b, b is 1/4, u equals minus 2. Similarly, a is 1/4 then, okay? By the way, for this type of partial fraction decomposition where the factors look symmetric, usually the a and b, the coefficients are the same. If not, this is just a sign difference. Here you can notice they're both 1/4. Okay, just a little tip. So I'm saying this because in an advanced electrical engineering class, we had to do these quickly in our head. So that's when I noticed these patterns. Instead of slowly doing it by hand every time, we had to do it quickly in our head like this. Okay, so then I noticed this pattern. I also first noticed that why was the professor able to do it so quickly in his head? And then that's how I realized. Anyway, beside the point. Okay, we broke up this into two fractions, so then they become easy to integrate now. All right, so this 1/4 I've, by the way, factored out in front to make things a little nicer. And these are just logs now. Okay, 1/4 ln of absolute value 2 plus u minus ln of absolute value 2 minus u. Okay, plug in the upper bound, we get ln of 3 minus ln1. ln1 is just 0. Plug in the lower bound, we get ln2 minus ln2, which cancels out, right? So we get ln3 divided by 4. And that's my answer. For this, you could maybe solve this in a different way, not like how I did it, but since it's a definite integral, you should for sure be getting ln3 times 1/4 as your final answer. No question about that. This is a definite integral. If it's an indefinite integral, you might have like a little slightly different form and it might be okay. But again, for a definite integral, no question about that. You should get ln3 divided by 4.